Hi everyone. I wanted to make a quick video to talk about something I've been having a lot of fun with in Houdini recently, specifically in Houdini 21 since they came out with the new simulation tools in Copernicus. It's kind of giving me a whole new world or new dimension, literally, of tools to be able to play with in a very Houdini-ish way that will make a lot of sense, especially if you're used to playing with solvers and SOPs. Now, with the blocks in Copernicus, we basically have the same thing. So let's jump in and let me show you some cool stuff that I've managed to figure out recently. All right, so I got a blank Houdini 21 session here. I'm going to make a geometry container just because that's normal. And then inside there, I'm going to make a COP network. And then in the COP network, I'm going to make a SOP geometry. There's a lot of different ways you can generate images and things in COPs. But I want to start off using some normal Houdini SOP geometry and then convert that. So diving in there, we're now in yet another SOP container. I'm going to make a sphere, and then I'm going to scatter some points on there. Let's do more like 50 maybe. Let's do a randomize the color with the attribute randomize, and I want to be able to see this better, so I'm going to press D over the viewport and go to background and change this to dark and close it. I'll turn off that grid as well. Then I'll do a attribute noise vector, which will let us change the position if I change the velocity to just be a P attribute. And then I want to turn on animation here. And now we'll see these points are kind of moving around in a crazy way. Let's make them move around a little bit less. Go down to the fractal, turn the roughness down, and then change the element size so that they all kind of move a little bit more independently. So great, this looks cool. We'll go back into Copernicus here, and I'm going to take that geometry and plug it into a stamp points. And now this is stamping a bunch of squares, which I could change to circles, onto all those points. Now, let's say I want to randomize sort of the scale of these circles. We can easily do that just by going back in here and adding another attribute randomize and setting it to change the P scale. We'll go back over here, and now we have random scale for each of these things. So now, great, we have this like rasterized 2D version of this thing that we're doing at the SOP level. I'm going to go ahead and take this RGBA data, which you can tell it is because it's yellow, and I'm going to plug this into a block, which is not going to work because it doesn't have any inputs to begin with. But a block, when I add an input here, is going to plug in and create an RGBA input for us. And I have to create a output as well, which can plug into there. And now if we turn on simulate, this essentially is going to behave just like a solver, which is why we're not seeing any animation happening yet. It's just the first frame, and then that's feeding back into the beginning, and we have this recursion where we're just seeing the one thing. If you wanted to, you could do something like add a blur here, and then you would see over time it's going to blur out every single frame. It gets blurrier and blurrier. But what if we want to take this animation here that we have and update that every frame, or apply that on top of the sort of recursive animation that we have in here? You can read updating input data into a block using another input and setting it to be the type cable. And cables are a really cool concept where you can carry groups of data together using a cable like this up here. And then you can use a cable unpack and plug this into here and set the fields from input, and then now we have all three of these outputs. So it's a good way to kind of like organize and move data around, but that's not how we're using it here. We're just using it to signify that this is basically like a pass-through for the sim. And I'm just going to type pass-through for good measure here, and I'm going to type in color here for good measure. And I'll also call this color. And so I'll plug this output into the pass-through here. It knows that it's just an RGBA thing. It'll tell us that it's yellow here. And then I'm going to use an over operation, and I want to set this to be the foreground and that previous frame to be the background. So I'm going to plug that in here like that. Great. This will play, and then cool. Now we have it sort of, all these points are kind of drawing on top of one another, which is a pretty cool sort of effect, and they're blurring out every single frame too, which is pretty neat. And so now we have this awesome kind of like recursive effect happening, and there's a lot of really cool things that you can do with this now. I could also multiply constant the previous frame, and we could set it to be like 0.95 or something. So then it will kind of like fade out as it's drawing. And you can play with these values. You can go over one and see what that does. That kind of brightens everything up and makes everything turn white, and eventually kind of breaks the sim. You can reset the sim here. I think that maybe we want these things moving more slowly. So I'm going to go back into this attribute noise here and just lower the amplitude so that they're not moving as crazy of an amount. And then we'll start over here, and I'll set the multiply constant to 0.95. You get this really cool kind of, again, like color drawing all over the screen effect. We could also, another cool thing you could use in a solver is a transform 2D. So if we now take this and we use the viewport handle, you can move it around and see, okay, now because I'm moving the points down to the left every frame, they're kind of moving in this direction. And you can move it around live and sort of play with it and get a really cool, trippy kind of, reactive effect. And, create this cool screensavery vibe. You could also rotate it. So now they'll kind of like spin like that. Transform is another fun thing to mess with in here. Another cool thing is using a sharpen node in addition to a blur node. Then you end up creating these cool, almost kind of reaction diffusion-y patterns, but you can break things pretty easily. So, be careful with messing with it too much, but can be a pretty cool effect. It seems like the reason that it breaks is if you have values that start going way over 1. So if you just clamp here, it should kind of fix that situation. So now we're good. We're able to go crazy sharpening stuff, but you end up not really necessarily breaking anything. And again, Copernicus is just basically the same thing that we have in SOPs and Houdini, but just now we're working on 2D images. So it opens up a lot of really interesting possibilities, and you can just create some really, really cool effects. And just playing around with these things will get you to super interesting results. I highly recommend just thinking about ways that you can kind of affect and distort your images and cops, and then think about how that would work recursively if you use it in something like a solver, what you can do with that. Speaking of distorting, there's a really awesome distort by slope setup in here that we can use, which is 2 nodes. This is the distort node, which needs a direction, and that direction is generated by the slope direction, which needs some kind of mono or height map input. So if I make a fractal noise, you can generate a noise pretty simply in cops. I'll turn up the amplitude, and you can play with the settings in here and figure out what you want the noise to look like. If you turn on 3D noise and turn on animate, it will animate, which is pretty awesome. Plug that here into the slope direction, and it basically converts it into directional coordinates for the distort to distort the image that you're feeding into it along the lines of. So now if we look at it over here, basically, we can tell it to scale things out along the direction that it's input, which is making it so that the white parts are sort of expanding out and the dark parts are going inwards. Or you can do the opposite and make the dark parts expand and the white ones sort of contract. But you could also, distort like any other image, and I'll use a file to bring in our default butterfly here, and then we can see what this looks like if this gets distorted. Kind of a cool little effect. And we can distort our stamp animation thing here. We can make the noise maybe a little bit different. Let's make it so that the roughness is lower, so it's like a little bit more of a low frequency displacement, and we'll distort it even more than that, and then plug this back into it. We'll see, cool, we get this weird blobby kind of effect. You could feed this back into the solver in here, but you could also distort it within the solver. So we could say, let's have this feed into here before it's doing kind of any of this stuff. And, the order of operations matters, and plugging it in different places will kind of create different effects. I'll turn off the sharpen and the blur, and you can kind of see, how this is working now. But anyway, another really handy thing to play with, you can sort of like advect stuff in a 2D space within your sim, which is pretty cool. But there's actually other solvers built into Houdini 21 now, so you don't just have to make your custom ones completely from scratch. We can use the reaction diffusion block here, and if you see, you'll need to plug in something for the activation here, or it's not going to have any input. And that's looking for a mono channel or a height map. So we can take this stamp and we can do a RGBA to mono to convert that correctly, and then feed that into the activation here. And if we play that now, then we'll end up with this really cool reaction diffusion sim, which is pretty awesome. You also don't need this to be a sim. You could turn this off and, change the number of iterations and treat it kind of like a for loop where it's sort of running, 5 steps of the solver per frame on every single frame. You can change the iterations per step and perhaps end up with some kind of cool results here. Yeah, super fun to kind of mess with things in this way as well. But let's go back to simulate, because that's where sort of the real fun stuff is happening, I think. And let's now do the same thing where we distort our chemical within this setup here, so that our reaction diffusion setup is forced to kind of move around, and we can use less of it or more of it. We can do all the same exact things that we were doing before in the regular block within the reaction diffusion one. I think we could probably use a blur in here if we want. But you can also go and dive in and see, and play with these sliders live as it's simulating, see what that kind of does. You can dive into the block begin here too and see actually what's happening and what all the different nodes are in here, and the little OpenCL snippets and things that they have driving parts of this as well. So it's a pretty complicated thing, but you can get in there and break things and copy things and use them in other setups. It's Houdini after all. So another thing worth noting is, again, like, keep in mind the colors of the inputs and the outputs. They kind of need to match up. We have these UV coordinates here of the stamp points that will sort of show the way that these UVs are looking on the stamp points, which are kind of giving us a directional interpretation of the stamp points. So, we can plug that into the pass-through here, for example, and then maybe use that to be the distort direction. And if we do that, the results are pretty subtle. But if I crank them, you can see, okay, now we have it sort of forcing this stuff to move out along wherever these sort of dots are. Okay, so another really awesome kind of solver that's built in here is the flow block, which requires some kind of color input here. I'll plug that stamp in there. And we'll see we get some really cool fluid sim-like motion built in here. I can plug in something for the velocity, which we can also use that UV for potentially, and end up with, if I reset it, it'll kind of push things out in that direction. And we can do the pass-through again, and I can go feed that color also into the pass-through, and we can do a blur over the color again, and we can do an over operation where we'll use that new stuff as the input, and then now we're getting these kind of swirly patterns. I can do another multiply constant here to kind of recreate what we did before. So it's similar to the one that we had with the just the block, but now we have this extra kind of like fluid simulation-y motion here. I think it would be cool to also try turning off simulate on this and just turning up the iterations. And maybe we could add some kind of noise into the temperature component here. And then we'll see it kind of moves up due to the buoyancy, which is kind of neat. I'll turn off the blur. Also, I don't know if that's helping. I'll turn off the multiply constant, and maybe I'll just have it so that it's kind of like this now, where it's just bringing in that sim. We just have this weird kind of like fluid sim happening with some kind of iterations every frame. I think I could make this this noise less rough maybe, and that would make it so it's less crazy. So we can put it back on simulate mode, and we'll get this again, this cool like simple fluid sim thing happening. But what's cool is we have this velocity output here now, which is showing us the direction that all this stuff is sort of moving in. And again, you can dive back in here and see everything that's going on, and it is essentially, a 2D version of like a fluid sim, where, they're doing all the same kind of things with the project non-divergent, pressure projection stuff, and it's just running the same things every frame, just like in normal Houdini or in DOPS, but this is in purely 2D using Copernicus. So now we have this cool velocity data here, and we could plug this into this pass-through here in the reaction diffusion, and then you end up with kind of a reaction diffusion sim that's being advected by a flow, fluid sim thing, which is pretty awesome. You could also, plug this back in over here into another input, and we could now have this distort happening every frame, being infected by this sort of like fluid flow sim. So lots of really cool possibilities, and I've just been kind of screwing around with this stuff and playing and seeing what kind of funny weird things I could come up with, and coming up with different ideas and testing them out and screwing around. Houdini's becoming a lot more like Touch Designer in so far as it's getting better at doing this sort of compositing type stuff. And also, you can turn on this live simulation mode now, which essentially just lets you, I'll toggle it on all these things, and live simulation, toggle it here. And now, basically, like, even if I stop Houdini, it's still going to just kind of keep simulating, and you can do sort of like live visuals or whatever within Houdini, just like as if it were Touch Designer or something like that. So it's pretty exciting, kind of like all the possibilities that open up here. And I'm really just kind of scratching the surface, and I have a lot more to play with and learn. But I strongly recommend testing things out, stacking them, turning nodes on and off. It's a combination of sort of like understanding what you're doing, knowing some math, knowing some proceduralism, knowing some Houdini, knowing some compositing basics, and just kind of like screwing around and playing and, having these hypotheses and testing them out and, seeing what gives you cool looks. And I'm just having a total blast doing that so far. So I hope that this tutorial was a helpful kind of jumping off point for doing some of this simulation stuff within Copernicus. And I hope you find it as much fun as I've been. And hopefully you figure out some really cool stuff yourself. If you do, please join the HoudiniNerd.com Discord and share some stuff in there, or tag me in some posts. Would love to see what any of you can come up with. Thanks so much, and have a great day.